This video is about tangent planes. Tangent planes can be defined explicitly or implicitly. Explicitly would be defined as z equals a function of x comma y, or implicitly would be a function of x, y, and z equal to 0. A function of x, y, z, or an implicit function, has a tangent plane with equation the partial derivative with respect to x of a, b, and c times x minus a plus the partial derivative with respect to y of a, b, and c with times y minus b plus the partial derivative with respect to z of a, b, and c times z minus c equals 0. And the explicit function z equals f of x and y has a tangent plane equation of z equals the partial derivative with respect to x of a and b times x minus a plus the partial derivative with respect to y of a and b times y minus b plus the function of a and b. This is an example from chapter 14.7, number 10. We have x squared plus y cubed plus z to the 4th equals 2. And we want to find the tangent plane at the points 1, 0, 1 and negative 1, 0, 1. So we have an implicit function. So we're going to use the first example of the tangent plane equation. So we want to first find the gradient of f of 1, 0, 1, which would give us all the partial derivatives. So it's going to be 2x, 3y squared, and 4z cubed. And when we substitute in the point 1, 0, 1, we get the gradient 2, 0, 4. So then we're going to use those values to substitute it into our formula. So we're going to get 2 times x minus 1 plus 0 times y minus 0 plus 4 times z minus 1, all equal to 0. And then we get 2 times x minus 1 plus 4 times z minus 1 equals 0. And that would be our equation of a tangent plane at 1, 0, 1. We would follow the same process for negative 1, 0, 1. The gradient is going to be 2x, 3y squared, 4z cubed, but then when we substitute our point, it will be negative 2, 0, 4. And then we're going to substitute all that in to get negative 2 times x plus 1 plus 0 times y minus 0 plus 4 times z minus 1, which is going to simplify out to negative 2 times x plus 1 plus 4 times z minus 1 equals 0. Then we're going to do another example, chapter 14.7, number 20. So we have z equals sine xy plus 2 at the points 1, 0, 2 and 0, 5, 2. This is an explicit equation, so we're going to use the second formula that we talked about. So we're still going to find the gradient of z, which is the gradient of the function xy, and we get y cosine xy and x cosine xy. And then at the point 1, 0, 2, we get 0, 1. So z equals sine of 0 plus 2 equals 2 for the function. And then we're going to substitute that in, and we're going to get z equals 0 times x minus 1 plus 1 times y minus 0 plus 2, because 2 was the function at the point 1, 0, 2. And that simplifies to z equals y plus 2. So that's the equation of the tangent plane at the point 1, 0, 2. At the point 0, 5, 2, we follow the same process, except that our gradient of z is going to be 5, 0. We end up getting the same answer, which is 2 for the function of z, and then we're going to substitute that in and get 5 times x minus 0 plus 0 times y minus 5 plus 2, and then that simplifies to z equals 5x plus 2, and that is the equation of the tangent plane at the point 0, 5, 2.